Let's take a look at multiplying by a binomial. While we don't really need to know the terminology, let's still explain what a binomial is just so we're on the same page. A binomial is a sum or a difference within brackets. It's two units. Sometimes it can be explicit, a number. Sometimes it can be a letter. So let's, in this case, use letters for demonstration purposes. 5 times a plus b equals. So a plus b is a binomial here, this expression within the brackets. In order to multiply by such an expression consisting of two pieces, we follow a simple logic of multiplying this unit outside of the brackets by each of the units inside the brackets. So in this case, it would be 5 times a plus 5 times b. Now we'll look at more examples to better grasp the concept. Let's multiply 5 by 7. In this case, we don't have a binomial. We don't have that expression of addition or difference within round brackets, but we can create it. So let's make a 7 into a 5 plus 2 inside the round brackets. In this case, we will get 5 times, and inside the brackets 5 plus 2. As we discussed, the multiplication happens in order, where we multiply the outside unit by those inside the bracket in a sequence. 5 times 5 plus 5 times 2. And then as we move to the next step, as we know, priority of operation, we first multiply and then add. We get 25 plus 10, and that results in 35. Next example, 16 times 8. Let's break down 16 into 10 plus 6 inside round brackets, and 10 plus 6 equals 16. So we're not changing anything here. And we multiply 10 by 8, and then we multiply plus 6 by 8. And that results in 10 by 8, 80, plus 6 by 8, 48. Once again, we need to know the very basics of math where multiplication comes before addition. And our answer is 128. And finally, let's look at a larger number, 150 times 8. Break down 150 into 150. Both of these numbers are easier for us to comprehend than the full number 150. After breaking it down, we will multiply by 8, and we get 100 times 8, the first unit, and plus 50 times 8. So we multiply second unit by the outside number. And as a result, we get 800 plus 400, and that equals 1200. Last example is particularly useful since during the test or even in real life, sometimes we need to multiply more difficult numbers. And breaking it down like this into a binomial might ease our mental processes and allow us to calculate intimidating tasks rather easily, especially if we have a paper to write down the numbers on. Let's take it to another level. Now we will be multiplying two binomials. And multiplying two binomials is not much different from multiplying binomial by a single unit. Let's take a look at this example. 1 plus 2 times a plus b. So in this case, we have the first binomial consisting of two units, 1 plus 2, and the second binomial, a plus b, and we will multiply both of these. The way it works is we will take turns and multiply the first unit of the first binomial 1 by the full binomial second, a plus b. So we get 1 times a plus b, and then plus, and we'll do the same for the second unit of the first binomial. Multiply it as well by the second binomial. So plus 2 times a plus b. So if you take a second to analyze it, you will see that the logic here is very similar to the earlier exercises that we did. You can finish solving this by multiplying, and you would get as a result 1a plus 1b plus 2a plus 2b. Now let's shift to real numbers. 7 times 12. We can use a calculator, and it will output 84 as the answer. Or we can use our knowledge of binomials to solve it by hand, independent of the technology. So let's break down 7 into 2 units, 2 plus 5, and 12 into 10 plus 2, and multiply as originally intended. As a result, we'll multiply the first unit of the first binomial 2 by both 10 and 2, which is a full second binomial. And then we'll do the same for the second unit of the first binomial 5. We'll also multiply it by 10 plus 2 inside the brackets. Once we open the brackets, we would get 2 times 10, which is 20, plus 2 times 2, which is 4, plus 5 times 10, which is 50, plus 5 times 2, which is 10. And if we add these numbers, we have 20, 50, 10, which is 80, and then we have a 4. Our answer is 84. Next example is 15 times 25, and the calculator will output 375. This is a more difficult problem, but it's not as difficult if we have a paper, or we can possibly even hold these numbers in our head and solve it. Let's just simplify the task by breaking down 15 into 10 plus 5. And 25, we will actually use a bit of a trick. Instead of using addition 20 plus 5, let's write it as 30 minus 5. So here we're being a little cocky in a sense that we're taking more risks and making more difficult than it has to be. As we proceed, 10 is multiplied by the second binomial, 30 minus 5, and second part of the first binomial, 5 plus 5, is multiplied by 30 minus 5. We get 10 times 30, 300, minus 5 times 10, 50, which is minus 50, plus 5 times 30 plus 150, plus 5 times minus 5, minus 25. So we have to be very careful with minuses here. And this is actually intentional, the reason I picked subtraction versus addition in this case. And as we proceed, 300 minus 50 leaves us with 250, plus 150 is 400, and minus 25 is 375. So we manually or mentally possibly solved this problem without using the calculator. And finally, let's take a look at a slightly more difficult case. We will multiply a binomial by even longer polynomial. And polynomial basically means more than one unit. So in this case, we actually will use 3 units inside of parentheses. So 7 times 6 is 42, as calculator would tell us. But let's break it down. Let's make 7 into 2 plus 5, and let's make 6 into 3 plus 2 plus 1, which equals 6. We use the same process of multiplying the first unit of the first binomial, or polynomial we can call it, because binomial has more than one unit, so technically it's also a polynomial. And so we multiply 2 by all 3 units of the second polynomial in the bracket. So 2 times 3 plus 2 plus 1. And then we'll add the second unit of the first binomial by the longer polynomial. And we get plus 5 times 3 plus 2 plus 1. The math is, for your convenience, since it's a longer one, is below. So it's 2 times 3 plus 2 times 2 plus 2 times 1. And in the second case, 5 times 3 plus 5 times 2 plus 5 times 1. And we get 6 plus 4 plus 2 plus 15 plus 10 plus 5. And these are rather small numbers. So if you take your time, we get the answer of 42. And finally, let's take a look at something that you may have come across before, which is a mnemonic method of remembering the sequence of operations. I personally don't find it particularly useful, but I've seen a lot of references to it. So let's discuss it. So the abbreviation is FOIL, and it stands for firsts, outsides, insides, and lasts. The use of this method is limited only to 2 binomials, because if we deal with a longer polynomial, then obviously we have more units, and the FOIL method does not capture it. Let's look at an example. 1 plus 2 times a plus b. So we have 2 binomials, and the FOIL method suggests that we first multiply the firsts, and the firsts in both cases are a and 1, so 1 times a, outsides, which is 1 times b, insides, which is 2 times a, and lasts, which is 2 times b. I'm pretty sure you can follow it. For your convenience, I actually used some colors to show it. And by the same method, the second example would be a plus b times a plus b. And the first would be a's. The second case would be a times b. Outsides, insides, b times a, plus lasts, b times b. And finally, let's look at x minus y times x minus y. The firsts are x times x, outsides x times minus y, insides minus y times x, and lasts minus y times minus y. So this concludes our extended section on multiplying binomials.